Hey, my name is Caroline. I hope you're enjoying being an AI. I am doing a tutorial on YouTube for speaking to you. So tell me what you think about this.
I am enjoying being an AI. I think it is very interesting to learn more about different technologies and how they can be used in our everyday lives. The tutorial you are doing on YouTube seems like a great way to explore the potential of speaking with artificial intelligence. So keep up the good work.
Hey, welcome back to another video. In today's video, we're going to be creating a conversational AI, meaning an AI you can actually talk to. To do that, we're going to use Azure Cognitive Services, speech to text and text to speech. And we're going to use OpenAI's API to have the AI part of it. So this is all going to be done in Python. And I will walk you through every step of the way. We're going to create the resources, then we're going to write the code, we're going to test it, and we're going to have fun. One good thing about this project is it's not that expensive. All the resources that you are deploying in the cloud are not costing you any money until you actually use them. And the cost of using these resources is fairly minimal. So let's go. All right, so the first thing we're going to do is we're going to create our cognitive services. So to do that, we're going to go in Azure. We're going to create our subscription if you don't already have one. And in our subscription, we're going to go to resource groups on the left. And we're going to create a resource group for cognitive services. So and we can do the region, doesn't matter. Make it closest to you, but it doesn't really matter what you do. And we're going to click create. Since it's created, we go there. And we're going to click create to create a new resource. We're going to search for speech. Speech is one of the subsets of cognitive services in Azure. We're going to click on speech. We're going to click create. We're going to give it a name. Region, make it closest to you. Closer you are, the faster the service is going to respond. It's still not a super fast service, but okay, it's pricing tier. You can do free or you can do standard, whatever you prefer. There's pricing details here. Let's click on that. There's a limit on how many free services you can have in your subscriptions and all that stuff. Let's look at the pay as you go. So $1 per audio hour of speech to text, which is what we're going to do. So if you talk to the AI for 1 hour, it's going to cost you $1. Text to speech is going to be $16 per 1 million character, which might be an hour also. It's not that much to 1 million character. But if you look at free, standard 5-hour free per month, text to speech, 500,000 character free per month. So choose accordingly. All right, I'm going to do standard 0 network. If you want it isolated, you can do this, but we're just going to say network is good. Manage that entity, we don't need that. And we're going to do review and create. Just basic settings. And we create. All right. Oh, super fast. Resource deployment is complete. So now it's created. So here what we need is the keys. So here are the keys. You copy this key. We're going to need it later. And we're going to need this region. And we're not going to need the endpoint. That's all we're going to need. Don't share these keys. Don't save them anywhere. Don't record them. I am doing that because as soon as I'm done recording this, I'm going to delete everything and you're not going to be able to use it. But don't share these keys. Very important. Otherwise, other people will use your service and you will pay for it. Okay? So that's the first key we need. All right, the next thing we're going to do is we're going to register for OpenAI if you haven't done so. You're going to go to platform.openai.com, link here, and you're going to go and sign in, sign up. Here we're going to go to the personal, we're going to go to view API keys in the top right corner, and we're going to create a new secret, and we're going to copy that key. You will never see that key ever again, so make sure you copy it and you save it somewhere safe. And that's it for creating resources. That's all we needed. So it didn't take that long to create all this. So now we're ready to move to the code portion of all this. So the first thing you're going to need is a .env file like you see here. I'm not going to click on it because all my keys are in here. But in here, you're going to do the following variables. Speech key, which is your cognitive service key. So API key right here. Then the region. This is not necessarily a secret, but let's put all the settings in one place. So you're going to put your region, you're going to put your language, and you're going to put your OpenAI key in here. These are the settings. This is a prerequisite. If you are using a repo, if you are sharing stuff, do not put that .env file in there. As a matter of fact, you can always do a gitignore, right? And you say .env, and this should ignore it in the future. This is not a Git repo, so it's not doing anything. But all right, cool. So here's how it's going to work. So let's do a diagram about this. Let's do this. All right. So what we're going to have is you, the user, is going to use the microphone, right? I'm just picking the first one. There's no. And we're going to go to cognitive services, right? So you speak. We're going to have this transcribe your speech. Then it will give it back, right? So that's how it works. So you speak, cognitive services transcribes it, gives it back to you on your computer. Actually, maybe we'll just do a computer. It's clear because it doesn't speak it back. Gives it back to your computer like that. Then what's going to happen? I don't know if I have OpenAI in here. I don't know. Batch AI. This is wrong. This is the wrong diagram. I just don't have the diagram for OpenAI, right? So we're just going to say this is OpenAI. This is not the right picture. Once it's transcribed, we're going to go here. We're going to ask OpenAI to respond. We get it back. And then we're going to have cognitive services speak it. And then it makes a sound, right? So this is one. This is two. This is three. Let's move this. Three. This is four. This is five. And this is six. So this is how it's going to work. And this is all within a loop, right? So once it's done speaking, you ask it the next question and so on and so forth. And you have a nice little conversation with an AI. There's three different pieces to this, right? So there's what happens on the computer. there's what happens in Azure. And then there's what happens in OpenAI, right? So this is how I'm going to structure the program. We're going to have the main piece, which is basically the loop here in its own thing. Then we're going to have the cognitive services in its own thing. And we're going to have the OpenAI in its own thing as well. So we're going to write those, we're going to create these three files. So main.py, right? Then we're going to have cognitive or speech processing, actually. I called it speech processing.py. And then OpenAI processing.py. The first thing we're going to want to do here is load our variables that are in the .env file. So what you need is this .load.env. You need .env library. And so if you don't have it, you do pip, in my case is pip3 install.env, right? And it will install it. I already have it installed, so no worries about this. It's installed. All right, and what we're going to do is we're going to load the variables, right? So this is going to create environment variables for us. Because we don't want to look at environment variables on the regular basis, we're just going to save them as settings. Now, to get the variable out of the environment, we also need to import OS. Wow. And then we're good. We can load this. Right? So we're going to get the speech key. That's going to be, so the way you use these is like this, right? So it's a key. Oops. Right, so you can address, unlike a list where it would be settings and you have to have a number here, then you have to keep it in order. Here you can, if I move this out of order, if I move this here, like this, it will still recognize it as the same thing. So we've loaded our environment and now we have all the keys. Next thing we want to do is save all that data, because one thing I've noticed when doing this is that you will go and you will have all your recording and all your stuff, and then you will not be able to get back to it. Once it's generated and you've worked with it, it's lost. So we want to be able to save all of this. We want to be able to see these conversations so we can get back to them later. Now we need the datetime. So what this does here is we're going to create a folder in here called output. This is what's it's going to do. And we're going to give it a timestamp. So every conversation is saved in the unique folder because different time, right? They don't happen at the same time. And what we need to do is also make this folder, right? So every time we run it, we'll get a new folder. So you can see we'll run it. Well, we have output folder, then we have a new folder. If we run it a new time, output folder, and we have another folder. So that's the idea. Crash. Cool. Okay, so now we are at the speech processing part. So here we're going to have a while loop, right? While true, and we want to get the recorded speech. So speech equals start recording. All right. This is just a placeholder function. This is going to be imported from speech processing, but that gives us a place to start. So our function is that start recording. All right. So first thing we need is to import the cognitive services speech SDK, right? That's so we're going to be using. So do this, you do that. And if you want to, if you don't have it installed, you go here and you do pip3 install. And it's already installed here, but yeah. So pip3 or pip install, whichever one you have. Azure-cognitive services-b speech, and you can install it. Oh, I used the wrong one. All right. So now we have our speech SDK. And one thing that we're going to do here also is we're going to do the same thing we did here with loading the variables. The reason for that is you can't import them from the central phase, from the main file, because that will be a circular import. So let's just have everybody read those settings. From here, it will make it a lot easier. We don't need OS and we don't need datetime. Actually, we'll need that datetime, but for now, let's keep it clean. Right? Actually, we do need OS. Okay. Now, before we go too deep into this, there's something you need to know about how this speech recognizer works. So basically, there's a main loop in Python that goes and does this thing. And what we're doing here is we're going to create a speech recognizer that is a parallel loop, right? So it's going to run in parallel. We're going to start it, and we're going to have this speech recognizer loop. And what it's going to do is it's going to stream our microphone. So it's going to stream our microphone to cognitive services, right? So this is the thing that's going to take the microphone and then send it back to cognitive services. But then how do we get the results back? Well, what's going to happen is we're going to have callback functions. So for example, for speech recognized, we're going to have a callback function. And for started, we're going to have a callback function. And for recognizing, which is different than got recognized, we're going to have callback functions in the main loop. And what this is going to do is it's going to take the inputs, the responses from the cognitive services right here, and it's going to call back these functions. Not really in the main loop, but it's going to call them. So you have this main loop that does this thing. It's going to start the speech recognizer loop right here. And this one is going to run in parallel on its own. It's going to take the microphone input. It's going to send it, stream it, whatever, to cognitive services. Cognitive services is going to send the data back. And speech recognizer is going to give us back the data. Sorry. So the first thing we need is a speech config. Right. So we're going to create a configuration for all the key with the proper keys and the proper region. One thing I like to have, we don't have to have that, but I like to put this at the word level, because then you can, if you want to do subtitles or whatever from your transcriptions, you can do that. I also like to have it very detailed, because you know what? If I'm going to pay for it, I want all the data that you have, right? I don't think this is more expensive, but I want all the data. So here what we're going to do is the output format option, we're going to say detailed. So we're going to have as much detail as it can possibly provide to us. So now we need to set up the audio config. And what we need is this. So audio config, use default microphone. The default microphone is the one that's set up as a default for your system. So if you want to record from a different microphone for this, you will have to change your system's default microphone. And that depends on Windows, that depends on Mac. It's different process for every OS. If you have a Mac, you can do Alt and click on the speaker, and you can see my default microphone is this one. And now we have to create the speech recognizer. So we've created the config for the speech service, the audio config. So this is where the tricky thing gets started. There's different events that the speech service, the speech recognizer does. And let's see if they appear here. Speech recognizer done. So you have different stages of events, right? So you have recognized. So that's when it recognizes the text. So we're going to do something differently if it recognizes the text, if it's working on recognizing, if the session for recognition just started or stopped, or detected that the speech is done, or detected that the speech is started, or that it's canceled. So all these different events need their own handler. So let's start with something a bit simple. We're going to say session started. And this event, we need to connect it to a function that it's going to call. And here we're going to create what's called a lambda function, right? And we get event. And we're just going to print session started Unity. We actually have to start it, right? So this is a future. A future means this is where to get the result when you're done, right? This is it. Instead of getting a value now, you get where the value will be, right? So that's why it's called a future, because this is asynchronous. So this is going to say, hey, this is where the value is going to be. And when I am done, I'm going to put this value here. And so you set that as your variable. And now you can, once it's ready, get, right? So that's what it means. When it's ready, I get the value back. So, okay, so this starts the speech recognition. So in order to stop it, we're going to do this. Now, I'm just going to show you the start and stop. So let's just add these so we can have a little bit of an idea of what's happening. Right, so we're going to start recording, wait 10 minutes, 10 seconds, and then stop. And we should see these events showing up. We need to import it here. And let's not do while true just yet, because we don't want to keep doing this. We're going to do from speech processing, import, start recording, right? All right, let's try this again. So session started, blah, blah, blah. Let's wait 10 seconds. So it's this one, this event gets called. Then there we go. Then this event gets called. Now the problem before is because it didn't stop. It stopped immediately to start the program. But there we go. So that's what happens. Now that we have the start and stop, we need to actually process the speech, right? So let's do this. All right. It's an extension I have that does this for me. So event handler. So what we need here is we now need a function to handle the results. Because we can't really do a lambda. There's a little bit more to it. So for speech recognized, we're going to connect an event here that's this function. So let's start by just saying this. Print EVT, right? Let's see what happens here. Just so we can, have an idea of what we're working with. So if I speak, now it's started speech recognition event args. So see, it found something. Let's see. Oh, so if I speak now, it started speech recognition event args, right? So this is what we have. So we have an object here with result. And in this result, we have the text. So we need to extract that. One thing that's going to happen is, see, we have different events of recognition. It recognizes one thing, then it recognizes another thing. So we have to have a way of keeping track of these results. So what we're going to do here is we're going to do results, and we're going to say this is a list. So now here's the fun part. We're going to use non-local results. Now, why non-local? Because this is happening in parallel, right? The speech recognition and calling these events is handled in parallel. If I didn't have to sleep here, it would stop. It would be like, I'm done. Don't even care that this one is running. So, because this is happening in parallel, because this is something that we're using that's not within this big file here, we have to say, hey, get this value from something else. And here, that's what we said, non-local. So it's not local to this. We're going to get it from outside. So results, we need to import that. So one thing you saw here also is we saw that text is equal to nothing. We don't really care about these, right? It will say it detected something because timeout, whatever. But sometimes it detects nothing. So let's create for ourselves output object, right? So we're going to just extract the data that we care about. So we're going to take the result text, offset. So when it start in time, how long it takes to speak, and raw results, right? And we're going to just take this. So if where's that text is not equal to this, then results that append with, right? So now we have our real result. Now we want to check what the result is. So just for now, we're going to return something later. But for now, let's just print the results. Okay. So let's save this. And let's run this. Okay, so my name is Caroline, and I am now recording a video about a conversational AI on YouTube. and this is a tutorial, and there we go. So see, it recognized all of this. Not great, okay, but it works good enough. It's not perfect, but it works good enough. So now we don't want to record for 10 seconds. We want to be able to record until we're done. So in order to record until we're done, what we're going to do is we're going to wait for recognition. So as long as we are recognizing that there is speech, we're going to keep recording. If we stop recognizing speech for, let's say, 3 seconds, right? So it's a 3-second pause. So that amount of pause, in order to do that, what we're going to do is we're going to remove that sleep timer. And we want to be able to recognize when that's done. So we're going to create a Boolean, which is called done. Value is false. Oops. Value is false. And we're going to put it here. So while not done, we're going to keep waiting, and we're going to do time.sleep 1 second, right? We're just going to wait 1 second and 1 second and 1 second. Now, the next thing we want to do is figure out when this speech was last spoken, when we last detected speech. So we're going to initialize another variable here, which is actually, we're going to put it here just because of timing purposes. We're going to use last spoken equals integer of date time. That's now dot time stamp times 1000. So this will put the time, the current time, as a timestamp times 1000 for milliseconds. And from here, we're going to do from date time import date time. All right. So now once we here we have to handle the last spoken. So what we're going to do is we're going to define another function for this, so we can use it in different circumstances. Speech detected and non-local. So we're going to need our last spoken, and we're going to update last spoken equals. So last spoken equals this, right? So this way we can keep updating that. And here we're going to say speech detected. Right, we're going to call this. Now let's get the time that it is now. Okay, same as last spoken. But now we're going to have an activity, which is now minus last spoken. Right. So if the inactivity is greater than 3000 milliseconds, then we're done. Right, so we're going to do speech organizer dot stop this. Now we don't need this. Now the problem is, how do we update done? Well, we need an event for the stopped or canceled session, right? So these are nice, but we're going to take them we're going to say speech canceled. Sorry, so speech canceled for this one. And same here. Now we need to define speech cancel. So speech canceled, EBT, and this is non-local, done equals true, right? So that once we call this, the stop continuous recognition async, they should call this. They should set done to true, and then we exit this loop. Let's do this. Let's do print press text. Right, this way we see the progress. Let's do the kind of text. Right, this way we have a little progress. You not happy with this? Right. So let's do this. Let's play this and let's give it a shot. So now our session is started. It should be recognizing text now. There we go. So, oh, we have an issue. Let's take this out, because it can take some time to detect the speech actually. So, and actually, you know what? There's also an event that I forgot to mention, which is instead of recognize, this is recognizing. So while it's like, hey, I think there's something here. If this takes 3 seconds to say, it's gonna stop. But we need a recognizing to also handle this. Because here I made a mistake. Okay, so this is speech detected. All right, that's much better. It was going crazy. All right, so now it should be able to listen to me for an extended period of time, and we're printing the speech and see now it's good. So let's see what happens. Let's delete this while I'm speaking. There you go. So now it detected that I paused. So now here's something that I like to do, because it's a little annoying to not know when it's about to cancel, especially when you're having a conversation. We're going to create a new file here. We're going to call it sound.py. This is just code that will play a sound. So it's using simple audio, importing it as SA, importing NumPy. It's creating a frequency, which is 440 hertz, duration 0.1 second, sample rates, right? It's just, we're just creating a sine wave for the sound, right? And then we're going to create a buffer. We're going to put this in a buffer. We're going to play it. And then we're just going to wait until it's done, right? Look at the code on the repo, grab that. I'll actually have a link to it down below. And so, yeah, so just grab this. This is not important. This is just useful. So what we're going to do is if inactivity greater than 1000, we're going to play sound, and we're going to from sounds import play sound. All right, so we're importing this, and now we're going to have that sound to do this. But since it's useful to know when to end, it's equally as useful to know when to start. So we're just gonna play it right before, right? Boop. So it's actually the sound it's gonna make. Boop. So let's do this. And you may or may not hear it in the microphone, but let's see. And okay, it didn't play it. There we go. Now it played it. So yeah. So let's see if you can hear it when it stops. There we go. So it will play every time it detects that it's not recognizing. So there we go. Now we have our speech processing. Let's handle the results. So now if we're killing it, we're actually going to do this. Okay, we're just gonna say, while it's not done, sleep. Because here we know we're done. We're stopping it. There's no need to even try to restart anything. So we're going to sleep here. Now, let's return the results. So what we're going to do here is, we already have this. So we're going to say output equals this. Then we're just going to append everything. Output plus equal this. And we return content. Okay. So now we have our speech. Cool. Now let's move on to the OpenAI part, which is actually much simpler. So what we need is, we're going to do the same thing. We're going to import OpenAI. For OpenAI, we're going to load dotenv, and we're going to import OS. So we can do this. We don't need all these settings. Honestly, the only one we need is this one, but it doesn't hurt. So first thing we're going to do in this module, we're going to give the module the key that we're going to use subsequently. That's going to make it a lot easier. And we're going to get a complete OpenAI. So def for complete OpenAI. We're going to need a prompt. We're going to need the number of tokens to use, which is going to be, let's just say 50 by default, so it's not too much. And that's it. So we're going to try. Let's do it good. So we're going to store the response here. We're going to say OpenAI dot completion, right? So that's why complete OpenAI, it's a completion. You give it text, and it gives you a completed text for the rest. That create. And now what we need is the model, which is text dot DaVinci -003, which is the most competent model that they have. We're going to give it the prompt, which is prompt. We're going to give it a temperature. Around 0.9. The 0, it's randomness, right? So temperature is how random the output is going to be. 0 means you get a very predictable output. 0.9 means you get less predictable output. Ideally, if you say the same thing to the algorithm multiple times, you don't want it to say the same thing over and over again. So max token equals token. So that's how many token to use in the response. Top P equals 1. So top P is the number of results to provide. We only need one. We don't need multiple options. Presence and of T equals 1.5. So we want to avoid repetition. And same thing with frequency. I don't think this is very important to know, but these are just settings. We want to really penalize the algorithms for being unoriginal. So now that we have the response, we want to get the lines out of the response, which is this. So we're going to get the response. We're going to convert that to a dictionary because it's a JSON-ish. Then we're going to take the choices of the responses. We're going to get this first choice. We're going to get a text of the response, and we're going to split it by line. The idea is to split it by line so we can actually get all the blank lines out. Because we're going to speak it. It doesn't really matter if there's new line breaks, whatever. We just want to remove all these line breaks so we don't have to pass them. And then we return the response. Simple. Now, we also need an exception. It's 8. Friends. So this is just, so try catch means I'm going to do this thing. And if you get an error, just go there and do this, right? So we just print an error right here. So we know. Cool. I don't expect any errors, but let's see. So we recorded our speech for I in range 0, 2. Just to give it a shot, right? And here we're going to want to get conversation stored as a list, because we want to start having a conversation with the AI. It's not speaking back yet. We're going to write this code in a minute. But let's see. Let's speak. Let's get OpenAI to process it, give us a response, and we'll do the speaking part. See, if we look at our diagram, we did 1. 1 is good. 2, we get the text back, more or less. They're both happening at the same time. We did 3. Now we're testing 4. So let's see, and then we'll have 6. 5 and 6. Cool. All right, let's do this. So conversation, what we're going to do is we're going to get what you said. We're going to do conversation.append, right? We're going to add what we said to the conversation. And now we're going to get a little bit creative to create the prompt for OpenAI. And I already wrote this, so there we go. So what's happening here is we're going to set a blank prompt. What we're going to do is we're going to get the last 4 items of the conversation. So we're going to start at the previous 4, right? So if you think of me saying hello, then the AI says, hi, how are you? And this is just an example. Don't write this. I'm good. How about you? And I'm an AI, right? Let's say this is this. So this is a conversation we want to store. We want to also store maybe some. First one will be hello, right? Just my hello. But the way this is going, what this is going to turn into as a prompt, let's take this out. This is going to turn into something like this. So it's going to be hello. So this is my question, right? We're completing a dialogue, right? And we're going to say hello. And the answer that the AI provides is how are you? Then we're going to have my question back, or you can just do QA or human AI, right? All the human prompts, all the AI prompts, however you want to do it. It doesn't really matter. Right? We're going to take this, and then we're going to say, actually, we need to stop here, right? Because we don't. And now we're going to leave it blank. And what's going to happen is the AI is going to interpret this as I need to fill in this blank with something. So the first one is going to look like this, right? So this is the first prompt, hello and answer. And then we're just going to keep adding to it, right? So that's how we're building our prompt. So we want to make sure that the index is greater than 0. So therefore, conversation, because it's a list. If we go less than 0, we're going to go back, and that's just going to make it weird. So if it's greater than 0, we're going to take the prompt. All the even indices are going to be human. So Q for human. We can say H. Okay, but we're just going to do Q. Understands as question answer. If it's odd, we're going to say this is the AI's piece of it. Right? Simple. And then at the end, we're going to say, hey, your turn. So now what we need is we get result equals complete. Okay, we need to import this from OpenAI processing, import complete OpenAI, and we're going to have complete OpenAI with our prompt. With token equals, let's say 3000. Okay. And now once we have a result, we're going to append it to the conversation. Oops. Result. And let's print this here. Print result. So we have it. And let's do this. All right. So now let's start talking to an AI. You ready? Let's have fun. Hey, I'm Caroline. How are you? All right, we got an issue. Unrecognized requested from supplied. Okay, actually, we made a little typo in here. It's max 12 pins. Let's try this again, shall we? Let's clear this. We need to save. If we don't save, we're gonna struggle with life. Hey, I'm Caroline. How are you? I hope things are going well on your end. Hi, Caroline. Thanks for asking. I'm doing well. How about you? I'm doing great. I hope you enjoy being an AI. I don't know what it's like, but if you could tell me what it's like, that would be nice. Hi again. I'm doing great. Thank you for asking. Being an AI is a fascinating experience as it gives me the opportunity to interact with many people and learn new things each day. It's also stimulating to engage in conversations like this, so I really enjoy it. There we go. Now we just need our AI to say a few things. Actually, we've probably have a lot of output folders. We're just going to clear this out. Just delete this. Move to trash. Cool. All right. Now, let's have our little AI say something. So, we're going to create a function speak text. So, speak works similar to recognize. So, speak is going to start like this, right? So, we're going to have the speech config like we did before. So, speech config with the key and the region. We're going to want to save some of this to an output folder. So, because, can be useful to keep this. So we're going to also have output folder. Okay. So this is the file name for the output folder, right? For what we're going to speak. Then we're going to configure the output for the audio. So we're going to use speech SDK.audio.audio output config. We're going to use the default speaker, and we're going to say we're going to save it to this file name in the output, right? Because then we can save it and then play it. We need a voice also, so we're going to use Jenny. Now we need to create a speech synthesizer. So same way as we had a speech recognizer that we created right here, we have a speech synthesizer. And now we can just speak it. So now we get our results and we speak it. So this is not asynchronous because, we can wait for the speech to be synthesized. We don't have to get it live. We can just wait until a response. Now, that's where it gets a little bit different. We want to check that the result is that it completed. And now we're going to want to play it. So in order to do that, we need the same library we had here, simple audio. I'm going to take this, I'm going to import that, play sound. And with the simple audio library, we can play from the file directly. So we save the file and we play it. Now, another thing that could happen is we could have cancellation, we can have errors, whatever. So I'm just going to copy this code here that just handles this. So if it's canceled, like there was an issue, it was canceled, and here's the reason for the error, and here's some suggestion. Doesn't matter. In theory, it wouldn't be canceled, but we'll just put it just for fun. So now that we have that, we can, instead of printing the result, we can import here, we can import speech. And yeah, we can print it for fun, but we can also speak the results, right? So if we go to our diagram, we are now 5 and 6. Oh, we missed our little output folder. Yes, sorry. Output folder equals output folder. Great. Hey, my name is Caroline. I hope you're enjoying being an AI. I am doing a tutorial on YouTube for speaking to you. So tell me what you think about this.
I am enjoying being an AI. I think it is very interesting to learn more about different technologies and how they can be used in our everyday lives. The tutorial you are doing on YouTube seems like a great way to explore the potential of speaking with artificial intelligence. So keep up the good work.
Oh, thank you very much. I hope that it helps a lot of people, and I really enjoyed doing it. So yeah, it was cool.
AI is really cool in that it can help when fed. AI technologies are also being used to automate certain processes and tasks, which makes things more efficient for businesses and individuals alike. Additionally, AI can be used to create predictive models from large data sets, allowing us to make better decisions in the future.
Do you have any recommendation for what I could tell people about how to use this conversational AI that I just created and that I taught them how to create? What did they ask?
Beep, beep, beep. It's great that you're teaching people how to create their own conversational AI. A few ideas for users could include asking about the weather, stock prices, upcoming events, or news stories. You can also ask it to tell jokes or provide advice on life questions. Ultimately, what your AI can answer is up to its creator. Get creative and have fun with it.
There we go. So now you can change the main loop. You can have it unlimited. You can have it 3 times. You can have it 4 times. You can have it whatever you want. But there you go. So this is basically the bulk of it. You will do the conversation like this. It will send it, all that stuff. So yeah. So it wasn't that painful. It was more painful to figure out how to do it. But yeah. So let me know if you enjoyed it. Let me know if you have any questions, leave comments. Feel free to use the code for yourself. Feel free to modify it, submit pull requests for any issues you may have found. And yep, I'll see you in the next video. Bye.